Good day, everyone. Good day, everyone. So we're starting today with we're going to finish this week. We're going to finish this week today, and I'll try my best to brush up everything I've done in this slide. Hope I'm audible, so I will share my screen right now. Right. Okay. So once again, good day, everyone. Good day from wherever. Um, name's Nemeka, and your host for today to talk about the transformer library. And I know I showed you the transformer library last last week. Sorry, this week or is it this week? Okay, last week, yeah. I showed the transformer library and about it, and even though it's like a was a spoiler, but so we'll look at it like strictly today, and I'll try my best to just put you through everything about it. So transformer library is just like every other library in machine learning, like scikit-learn, pytorch, TensorFlow, JAX, right? It's just for you to like train your, in this case, LLM models, or your machine learning your LLM models, or LLMs, whatever, right? It helps you to like easily download and train your pre-trained models like the BERT models, GPT-2, open source models out there, they still BERT are better, all of them. I will show you like the interface very soon. So um it also like helps to reduce like compute costs, right? Because they have found a way to optimize the way um we train models. The library on its own has found it, like the owners of the authors of Hugging Face library found a way to like optimize the model training and also the model storage and all of that, right? There's something about the carbon footprint. There's a particular article on the amount of electricity and power, whatever that was used to train GPT-3, right? So because you don't need to train yours again, you just need to like load them, fine tune them for your own use case. It really reduces all of that. And also it doesn't really training time because you don't really need to train yours. Right? And the transformer model has the capacity to support the different types of tasks in various modalities. And I would say modalities as in like different like fields. Like there's natural language processing, that's most likely text related or language related. There's a computer vision, that's most likely image related, image classification, object detection. Like transformer library has the ability to handle all of that. It also has the ability to handle audio. So you have something like ASR, speech recognition, and also classification. It also has the ability to even do um, speech to text, right? Speech to text as in you've said something, right? And it also helps to convert it to text. So Hugging Face also has models for that use case. And also it also has the ability for multimodal tasks too. That is video classification, video audio detection, and all of that. Also, anything has to do with image and text. So, there are some models that have the ability to take in images and also take in text at the same time, like your stable diffusion. I think there's one, it's mostly stable diffusion is closed source, but there are open source versions of that. And Transformer Library also has that ability, right? Also, if you build a transformer model, like the transformer library that's Hugging Face, provided by Hugging Faces. Hugging Faces is a company actually that provided this framework for us, right? And so they have the ability to, switch between whatever frameworks you are already using in your company or your application, right? So there's a way for you to build your models with PyTorch. There's a way for you to build or train your models with TensorFlow, depending on the syntax you're familiar with or your company already uses in their code base. So it has the ability to use these three frameworks. I don't know if JAX is that popular to you guys, but it's very, very popular in AI research field, right? JAX. So it's also supported by Transformer Library. Also, what it also helps you do is something like if you're familiar with scikit-learn, where you just like do .feed, .predict. It helps you to train your models in a few lines of code instead of writing all of the PyTorch code from scratch again, depending, right? You just want to use their models, just load their models and just do dot feeds or dot whatever methods those classes offer, right? You also have the ability to load models and also export your models for deployment in production. It's just the same thing as scikit-learn, or whatever, TensorFlow.save, all those things. It's also possible in transformer models to where you can save your models into files, whatever file format you use, or you can also convert them into better formats for faster inferences. So yeah, transformer models give you the ability to do all of that. So just for quick introduction, let me just go to the Hugging Face platform. So this is the Hugging Face platform, huggingface.co, and they have a whole lot to offer for you, whatever task you have. You could just go to the models. Oh, okay, I've got to say they also provide data sets too, right? They provide data set depending on what you want to do, right? You might have a model that you want to fine tune. You need a data set for that. Hugging Face also has a library of data sets for you, right? Depending on what you want to do. So something like text to CQ, right? Where you just give a particular text and right, you want it to give you the prompt for that. And all of that, even though I don't know what the application of. There's an application for it, but I don't really know the specific application for that data set. And so the models too, you see a lot of models here. You see the trending, you see the most likes, stable diffusion version, Bloom. Or these are models that this was a model that took surface some years back. Metalama, stable diffusion 2. There are a lot of that. The Mistral, the Mistral given by from Mistral AI company. They open source some of their models too. They also have the most downloaded. Is for most likely audio classification. Like you also see like some of their purposes here, or their tasks actually, not purposes, tasks. This is zero shot image classification, where you just, I think it's a clip model, right? It was used for, you put in an image and it will help you like convert it to like state what the um the target label is. And there's also for ESR and all of that. So it's a very, very fun library with a whole lot of like dependent like dependencies and a lot of community behind it, right? So depending also on the tasks, their data set for those tasks, and I really encourage you to like just look through it and see what it has to offer for you. And so for today, we'll just be looking at how to use the Hugging Face library for NER, name identity recognition, and question answering. Just for today. All right, it's most likely in your material. You most likely have seen it, but I will just walk through the code. If you have any questions, you can always ask me. Just this is the section for that. All right. So um name identity recognition has always been a task that has been out there, right, from the beginning of NLP, during the times of LSTMs, and it's been there even the times of maybe before all of that, where you just use naive Bayes and all of that. So it has been there, and it's just for like classification of like entities, right? Maybe you have a sentence and you want to identify every single name there, every single person, every single organization there. Right? It's a pretty basic task, but it's very, very complicated, right? So um you have a long text and you want it to maybe put that into structured data, like maybe into tables, right? You have text, you want to put all the persons into under a person label or person column, put every organization and organization column, put every location on a location column and all of that. So you can do that using this task named that NER. It's all under the task NER, right? And it's been there. And so today we'll just be walking through how to get all of this started using the transformer library from Hugging Face. It's pretty simple actually. You just need to come here, import the transformer, the pipeline. I think the pipeline. Okay, let's see if I can to their library, transformer, transformer, sorry, transformer library. The pipeline is like a higher level, um, is a higher level API, right? Instead of going down into like building like a more or like interfacing with the actual BERT model or whatever model, the pipeline just, what you just need to give it, right, is your task. It takes in your task, and also it also has a couple of parameters there. You can see you can pass in a task as a string, you pass in the model if you want. It can be a string, it can also be in a pre-trained model, and also a TensorFlow pre-trained model. It can also be none, and it will help you choose whatever model it can give you, right? And what else? Why is this thing not to work? Why is it not staying? Okay. So, and it provides the pipeline is made of a tokenizer and also like a model, right? So what it does is just like a higher level API, right? It helps you load the tokenizer, helps you load the model, tokenizes the text, and also passes it to the model for your use case, right? So it can be used for different tasks, audio classification, ESR, conversational, whatever task you want. It has a whole lot of use cases out there. So yeah, the pipeline is a very, very high level. Instead of diving deep into all the like the structure of the model, you could just use it in this case. So today we just specify any R, right? And what's going to happen is that since no model is supplied, it's just going to use the default, well, I will not say default, but actually the best model for this use case provided by Hugging Face. So if you go to the link provided, you will just see the model card, the version. There's a Python version, there's a Rust version actually, there's the TensorFlow version, and also a safe tensor version. Safe tensors are most likely to prevent any of all those to prevent some of these things might have bugs or um security flaws, right? So I think the Hugging Face library, Hugging Face or TensorFlow, Hugging Face came up with a way to save these models weights, right, in a safe way, so that it will not be hacked, or there will not be a lot of um, hacks and bugs and vulnerabilities to your applications from this weights, right? So yeah, so he downloaded the model, and he downloaded the model, the safe tensor version, right? And the tokenizer, and also some configs for the model, right? The configs will be saved in config.json. It also downloads the vocab for this particular model used by the tokenizer. And so, well, like I said, in this pipeline, it's like something like a scikit-learn model. You could just call it like that. You saved it into this variable, and you could just call it with a provided text like, I am a Hammer instructor and my name is Nefta, like I said. And so when you just call it, it's going to help you, um, do the name entity recognition, right? So it's going to look through the text, do tokenization. Right, I'll show you do tokenization. After tokenization, it passes those tokens to the model, and the model will now determine the entity from the token, right? So, but if you look at it most especially, you see that he removed some of these stop words like I am a, right? He removed and my conjunction stop words, name, and he just kept those particular keywords that you're looking for, right? And if you also notice, though, you see that it splitted up the name Hamoye into Ham, OY, and E. And like I said, in tokenization, if you remember from the previous text, in tokenization, we split it into sub words, right? Those sub words will now be words that are bases, right? They'll be giving tokens. So instead of having some unknown UNK tokens, like UNK means unknown tokens, it will find a way to split those words into subwords, and those subwords could now have like more, not one words under them. Right? So ham actually is a word on its own, right? And it's also like it also has maybe like a token, a number to it. So it does that for the O, Y, and E. So you see that it was able to tell that this all of this from the start to the stop, right? What do you call it? It's an organization, and Amoi is actually an organization. It was also able to specify a person from that too, right? And like I said, it also splits the word Nemeka is an Igbo name because this is English, it's strictly English, right? It's strictly English, and this is not an English word. So it's going to find a way to represent this non-English word into English, right? So that's why the subword tokenization comes in, right? And so this is just basic anyhow. Like I said, this is a task, a very, very simple task. Simple for human beings, but not too simple for computers, right? Or for computers. So there's now the whole BERT model used in place. So the BERT model is just is based off, right, the BERT model. You can see it's BERT large. So the BERT large model was used here, and it was fine-tuned, right, with a specific what's it called? A specific data set, most likely con 103. So don't look at the name as something big, right? It's just using the BERT large base model, right? And it's fine-tuned using a particular data set, con 103. So let me see if the con 1 is open source too. I don't think it's open source. I don't think it's open source. Yeah, so I don't think it's open source. But if you look into it, most likely, maybe you see documentation somewhere. So yeah, it uses this for the task, and yeah, it works fine. It works fine. So so yeah, let's move on to the next task, which is for question answering. And this task is a very, very like complicated task, but also very, very important in the world now, right? Because it's basis for every single thing that is automated, like customer support bots, information retrieval, and also RAG, retrieval augmented generation that you see in this course in stage 4 or stage 5, right? So what it means is that it's going to provide answers based on questions, right? You have questions and you have this large knowledge base, right? That's open domain. You have this vast knowledge base, and you want it to answer those questions based on those knowledge and that based on that knowledge base, right? So what it means that you provide this, just like if you remember English comprehension back in the days of high school or secondary school or primary school, where you have this long passage and you have these questions, right, to answer for those passages, and you have to look through the passage and find the answers from there. So it's almost the same thing here. So you just want to, you have a question, maybe you have a very, very long PDF and you just want to ask questions based on that. So that's when question answering is very, very important, right? So the components of it is that you have a question, you have some context, and you want to answer that question from that. So the model will also be in charge of generating the answers, like it's going to find the info and also formulate the clear answers from there. So it's a very, very complicated task if you look at it. And back in days, it was very, very not easy to do that, right? So with the advent of the introduction of the LLM large language models, that's been pretty easy to do, right? Or not easy to do. It has been it the let me say there was a metric, right? There were these calls for Q&A, and over time with the invent of the introduction of large language models, the metrics have been going higher. Like so the scores, so right now the LLMs have scored higher than the previous models that we use, maybe the LLM, LSTMs, and whatever models they were used in this use case, right? Back in days. So as usual, okay. So as usual, we use the pipeline, the simple pipeline um, model pipeline um, um, library, sorry, a pipeline class or pipeline methods to just put in question answering, right? And what it's going to do is going to look into Hugging Faces um, and download the best model for it. Or if you don't provide a model, it's going to download a basic model for it, right? That's the distill bet. And the distill bet is based off the bet, but what's done in this case was distillation. Distillation in this was a technique where you reduce the size of a model by distillation. Distillation is a pretty complicated topic, right? But it's kind of outdated, right? It's kind of outdated. But if you look at it, distillation was proposed in the blog, smaller, faster, cheaper, lighter, introducing distillation. There's a paper behind that, or there's a Medium post behind that, and there's also a paper behind that too. And so distillation is just a smaller, faster, cheaper, and lighter transformer trained by distilling the bet-based model, right? So what that means is that they found a way to, maybe reduce those weights, right? Remove some weight, reduce some weight. Distillation. Distillation is a kind of outdated, but also important phase of read through all of what was done with the papers and everything, right? Internet is unstable. I hope I'm very, very audible. Saying my internet is unstable. Okay, let me continue. So what you just need to do is to give it the context, right? You have this context. Extractive question answering is the task of extracting an answer from a text given a question. Example of the question answering data set is core data set, which is entirely based on that task. If you would like to fine-tune a model on a spot task, you may leverage examples, blah, script. So this is just a very, very long text. So it could be longer, and you just like have this long text and you want to say, what's a good example of a question answering data set? And so you just put in a question, put in a context. These are all arguments to this method or to this object Q&A. Right? The Q&A object, these are the methods, question, and context. So when you do that, you assign it, it's going to give you, it's going to spit out a result, and in a result object or the result object, if you print it out, you see that it gives you a score, right? You can search on what this score means, but it's most likely how confident it is with that answer. It also pinpoints a part of this text where it was found. So let me try that and see. 147 to 160. Okay, so it gives you a particular indices of from that text where the answer was found, and it gives you the answer sports data set. So this is a pretty easy way. This is a pretty easy one. This is an easy one, but it's the light one. 261 megabytes, and right, it's compared to the 133 gig version of just the BERT large model. So you see why the DC BERT was brought about, was for you to have smaller, smarter, and cheaper ways of doing your NLP tasks, right? You just use even a small RAM to load this, and it will do the tasks that you want it to do. And depending on this is the bet large, and you see 1.3, you see the differences in all of that, and it's still performing very, very fine. It's still quite accurate for this particular task. So this is the end for today, right? I just wanted to like run through all of the labs and see if there are any questions. I see not many people joined the Zoom, but if you do have a question, you can always put it in the Slack channel about the Hugging Faces interface, the Hugging Face library, and what it does, and all of that. Right. So thank you very much. Thank you very much. Good luck in your test if you've not taken it, or the quiz if you've not taken it. Good luck in the future stages, and I hope like I'm able to explain as best as I could, the beginner stages of the LLM, of language or generative AI LLM, everything related to that. So yeah, thank you very much.